So, student, can you see my screen?
Yes, ma'am.
Okay. So, let us start today's class. Last day, I have discussed you about the hydrologic cycle as well as the water resources of India and the global water resources. And I have told that hydrological cycle is very uncertain dynamic cycle, and water may present within this hydrologic cycle in different forms, maybe in ice, in solid form, in liquid form, or in gaseous form. But you know that total quantity of water within this hydrologic cycle or within this hydrosphere is always constant. It is about 1386 million kilometer cube. Okay, and of which only 2.8% is your fresh water. 0.86% is in the form of your groundwater, and 2.2% is form of surface water. Okay, but also I have told you that all the surface water cannot be extracted. 2.15% are present in as ice in polar caps, and 0.01% is in atmosphere, and only 0.04% is within the surface water. Okay, so if you pollute the freshwater resources, you can see the freshwater resources is very limited, and obviously it will be polluted by naturally. But anthropogenically, if you pollute the water, but at the same time our population is increasing, so there will be the scarcity of water. And you also I also have told you that all the hydrological cycle, all the paths of the hydrological cycle basically has three things. One is your transportation, one is your temporary storage, and third one is your change of state. Okay, now if you all the circular paths are interlinked, so if man can interfere in any of the path, now if they will interfere in any of the path, then it will cause serious repercussion to other paths also. So these things I already have discussed in the last class. Today I will start with new chapter, that is precipitation. Now, what is precipitation? Precipitation basically denote all forms of water that reach the earth from the atmosphere. Okay, and usual forms of precipitations are rainfall, snowfall, hail, sleet, etc. Now, of this, the rain and snow contributes most of the precipitation. Oh, therefore, and also it creates the stream flow, flood flow of the majority of rivers. So that is why mainly rain and snow are considered as the precipitations. And in India, the snowfall only occurs in the northeastern region and northern Himalayan region. So, for our case, rain is the predominant form of precipitation. Okay, and the magnitude of the precipitation basically varies with time and space. Okay, varies with time of space. You know that maximum rainfall occurs in India in Cherrapunji, and minimum rainfall occurs in India in Rajkot, Gujarat. Okay. Now, therefore, this spatial and temporal variation of the rainfall causes various hydrological related problems like droughts and floods. Okay. Now, what is precipitation basically? How the precipitation occurs basically? Whenever the evaporation, last day I have shown you that basically hydrological cycle has no well defined beginning and well defined end, but it is convenient if we can start from the evaporation from the different water bodies, mainly from sea and oceans. Now, whenever this evaporated water move upwards, so therefore it moves from the low pressure region to high pressure region. Okay, low pressure region to high pressure region. Now, whenever it moves from low pressure region to high pressure region, it will cool adiabatically. Okay, it will cool adiabatically and forms clouds. Now, these clouds gets so packed with water molecules that they become heavy and will be subjected to the force of gravity at a faster rate than updraft in the air around it. So, at this point, precipitation occurs. Okay. So, therefore, for forming the precipitations, you should have sufficient moisture in the sufficient moisture in the atmosphere. Number two will be there should be sufficient nuclei. Okay, sufficient nuclei. Sorry, CLEI nuclei to aid condensation. Okay. Number three, weather conditions must be favorable. For water vapor to form clouds. I have told you that there should be sufficient nuclei for condensation. Okay, actually all the dust particles present within the atmosphere create the basically act as the nuclei for the condensation. Okay, so that is why always we are talking about that our environment should be free of pollution. But if there will not be pollutant, okay, there will not be the dust particles, then this condensation will not be occur. And finally, whenever this water droplets forms on the nuclei, it is of size less than 0.1 millimeter. Okay, so therefore it will float on the upper surface of the atmosphere as mist. Okay, as mist, so it will not reach to the it will not reach to the ground surface due to gravitational force. Okay, whenever there will be again sunshine, that 0.1 millimeter mist particles again evaporated back to the atmosphere. So that is why whenever the wind aids the transportation of the clouds, these tiny water particles will collide with each other and forms particles greater than zero point 0.5 millimeter. Okay, forms water particle greater than zero point 0.5 millimeter. Now whenever it will greater than zero point 0.5 millimeter, then it will reach to the earth. Okay, it will reach to the earth. So therefore the fourth point for the favorable conditions of the precipitation is the products of precipitation must reach to the earth. Okay, so if these four conditions will be fulfilled, then precipitation will occur. Okay, বোঝা গেল how the precipitation occurs.
Yes, ma'am.
ম্যাম সাফিসিয়েন্ট
Now,
ময়েশ্চারটা কিভাবে ডিপেন্ড করবে আরেকবার বলবেন?
নির্দিষ্ট কোনো পার্সেন্টেজ আছে ম্যাম, যে এই পার্সেন্টেজের বেশি হলে মানে ময়েশ্চার কন্টেন্ট যদি এর থেকে বেশি হয় তাহলে রেন
না,
হবে?
নট নট অনলি ওরকম পার্সেন্টেজ, ধরো হিউমিডিটি আমরা কি বলি, যেমন ধরো আজকে if you consider the weather conditions of today, okay, today the humidity is very high, কিন্তু হিউমিডিটি ইভেন স্যাচুরেশন কনসেন্ট্রেশনের বেশি হয়ে গেলেও 98-99% হয়ে গেলেও কিন্তু মোটমাট এই পুরো চারটে কন্ডিশনস ফেভারেবল হতে হবে। ঠিক আছে, হিউমিডিটি বেশি হলেই যে তোমার রেনফল হবে তা কিন্তু নয়। হিউমিডিটি দেখবে গরমকালে প্রচন্ড ঘাম হচ্ছে, কেন বলে বলে যে হিউমিডিটি বেড়ে গেছে, বাট দেয়ার উইল বি নো চান্স অফ রেনফল বিকজ আদার থ্রি things will not be favorable. You should not have to only the humidity, you should have the pollutant particles or dust particles. That is why you may find that there will be more chance of rainfall in city area rather than in the village area because of the presence of the sufficient nuclei. But even the cloud will form, the rain will not come to the atmosphere until unless there will be the favorable conditions. Okay, I will discuss all the favorable conditions. Then maybe the rain particles will form. Okay, the water particles will form, but it will not reach to the earth's surface. It will basically float on the atmosphere like mist. Okay, but whenever wind will aid create turbulence, then these tiny water particles will collide with each other to forms water particles greater than 0.5 millimeter. Whenever this will become 0.5 millimeter, then only it will reach to the earth as due to the gravitational force. Okay. Now let me discuss different forms of precipitation. I already have told you that precipitation will be known as rainfall whenever the particle size will be greater than 0.5 millimeter. But whenever it will be more than 6 millimeter, then whenever it will reach to the earth, it will tends to be broken into particle size 0.5 to 6 millimeter. Okay. And last day also I already have told you that generally the different water present in different parts of the hydrological cycle can be expressed in terms of depth if time interval is specified, and the area time interval and area extent is specified. Okay. So therefore the rain can be classified based on the rate of rainfall. Okay, rate of rainfall, that is known as intensity of rainfall. Whenever the rate of rainfall is greater than 2.5 millimeter per hour for a particular areal extent, then it is known as light rain. Whenever in between 2.5 to 7.5 millimeter, it is known as moderate rain, and greater than 7.5 millimeter per hour is known as heavy rain. Okay. Now, the second form of precipitation is snow. I told you that this also, after rainfall, snow also contributes much runoff in the stream flow. Okay. Now, what is snow? Snow is the precipitation in the form of ice crystals, which usually combine to form flakes with an average density of 0.1 gram per centimeter cube. But for India, snow is not very common. Then drizzle. I already have told you that rain droplets of size less than 0.5 millimeter and rain intensity less than 1 millimeter per hour is known as drizzle. So this drizzle generally not reach to the earth's surface. It floats on the atmosphere, and whenever the sunshine will come, then it will again evaporated back to the atmosphere. Then glaze. When rain or drizzle touches ground at 0 degree centigrade, glaze or freezing rain is formed. Hail. It is basically showery precipitation in the form of irregular pellets or lump size more than 8 millimeter. Most of you have seen this hail during the convective precipitation from March to May in West Bengal. Then sleet. It is frozen raindrops of transparent grains which form when rain falls through air at sub-freezing temperature. Okay. So these are various forms of precipitation occurs. Now, I told you that for precipitations, they are not only the atmosphere should have sufficient moisture as well as nuclei, but weather conditions should be favorable for precipitations. Okay, and based on the mechanism, the weather conditions are classified into four major groups. One is frontal precipitation, orographic precipitation, convective precipitation, and cyclone. Now, what is frontal precipitation? Frontal precipitation is occur whenever the two distinct air mass will meet with each other. Okay. And basically, front is the interface between two distinct air masses. One is warm air mass and another one is cold air mass. Now, whenever these two distinct air mass, the cold air mass and the warm air mass, will meet with each other, you know that the warm air is lighter than the cold air. So, it will move upwards. It will move upwards from high pressure zone to low pressure zone. So, therefore, it cool adiabatically and forms clouds, and if favorable conditions are there, then precipitation will occur. Now, sometimes the old cold air, it is known as basically warm front. Okay, this is known as warm front. But sometimes the cold air penetrate below the warm air. Okay, cold air penetrate below the warm air. So again the warm air will be move upwards, cool adiabatically, forms clouds, and if the clouds is packed with water, then it will cause precipitation. So this is known as cold front. Okay, this is known as cold front. This is one of the favorable condition of precipitation. Another one is orographic precipitation. What is orographic precipitation? Whenever the moist air mass get barrier, okay, moist air mass get barrier due to the presence of the hill or mountains, then it will move upwards. It will move upwards and cool adiabatically. Forms clouds. Now, if whenever it will be packed with the water, it will causes precipitation. And because of this is known as orographic precipitation. And because of this type of precipitation, the windward side, this is the windward side will have maximum precipitation rather than the leeward side. Okay. Third one is the convective precipitation. If the air of a particular region will get warm because of the some localized heating conditions. Okay, because of some localized heating condition. So therefore, the warm air, you know, is lighter, so it will move upwards. It will move upwards and to create voids, and to fill the voids the cool air will come from the other side. Okay, and this warm air whenever move upwards, it will cool adiabatically, condense, form clouds, and then ultimately result in the precipitation. Okay, now the areal extent of such precipitation is small, but intensity of this precipitation is very high. Okay, and in India during March to May, there are rainfall due to this convective precipitation in West Bengal, Assam, and Kerala, and it is also associated with the hail also.
Now, what is the cause
Then
of the local heating?
ধরো কোনো জায়গায় আগুন ধরে গেছে, এটা একটা হতে পারে। অথবা কোনো আগুন নয়, দেখবে যে এটা বেসিক্যালি কালবৈশাখী, বুঝলে? বলে যে তোমার ছোটনাগপুর বা ওই পুরুলিয়া, বাঁকুড়া বা ছোটনাগপুর এইসব জায়গায় হচ্ছে তো হিলি রিজিয়ন। তো ওখানকার হচ্ছে প্রচন্ড গরমকালে ওখানে প্রচুর তোমার ডিউ টু দ্য ইন্টেন্স সানশাইন, the air get evaporated and it forms move upwards, form clouds। আর যখন ওই হাওয়াটা, ওই ক্লাউডটা, তোমরা জানো যে উইন্ড উইল এড দ্য প্রেসিপিটেশন, ওই হাওয়াটা যখন বয়ে নিয়ে আসে মানে সিটি, বেসিক্যালি যখন ছোটনাগপুর, বিহার, পুরুলিয়া ওখানকার ওয়েদার যখন বেশি উত্তপ্ত হয়ে ওঠে, তখন আমাদের গাঙ্গেয় পশ্চিমবঙ্গে ইয়ে হয়, কি যেন বলে, প্রেসিপিটেশন হয় ডিউ টু দ্য কনভেক্টিভ প্রেসিপিটেশন। এছাড়াও আমি একটা কথা বললাম যে শহরে শহরে হিট আইল্যান্ড হয়। কি হচ্ছে, এই আমাদের সাউথ সিটির সামনেটাই দেখবে, বাঁ দিকে একটা বিশাল বড় শপিং কমপ্লেক্স, ডান দিকেও দেখবে বড় বড় হচ্ছে বিল্ডিং। তাহলে ওই মাঝের হাওয়াটা হচ্ছে ভিতরে বদ্ধ অবস্থায় থাকে। এবার যদি ইন্টেন্স হচ্ছে তোমার সানশাইন হয়, তাহলে ওই লোকালাইজড হিটিং ক্রিয়েট হয়। সো দেয়ারফর ইট উইল মুভ আপওয়ার্ডস, ফর্ম কুল অ্যাডিয়াবেটিক্যালি ফর্মস ক্লাউডস। এটাকে বলা হয় হিট আইল্যান্ড। সিটি এরিয়ায় এইরকম হিট আইল্যান্ডের চান্স খুব বেশি। সিটি এরিয়ায় দেখবে বেশি ইদানিং ফ্রিকোয়েন্ট বৃষ্টিপাত হয় রাদার দ্যান দ্য রুরাল এরিয়া, বিকজ অফ দিস হিট আইল্যান্ড। ঠিক আছে?
Yes, ma'am.
Then cyclonic precipitation. A cyclone is basically large low pressure region with circular wind motion, and the circular wind motion, and the low pressure region is the pressure is decreased so much that it is around 915 millibar. Okay, you know the unit of pressure is bar, so even it becomes 915 millibar. So cyclone is basically large low pressure region with circular wind motion and intensely strong depression with mean sea level pressures. Okay, and these cyclones are generally originated at the ocean and moves at a speed of about 10 to 30 kilometer per hour to higher altitude in an irregular path. Okay, and the aerial extent of such precipitation is very large. Now, whenever after forming in the open ocean, whenever it will moves towards the ocean, then it gain energy from the ocean, from the water, from latent heat. Okay, latent heat. Now whenever it reaches to the earth surface, land surface, basically there will be the cut off source of energy. So it dissipates. Okay, but it creates a high damage of life and property at the path of the cyclone. Okay, and cyclone are of three types. One is tropical cyclone, one is extratropical cyclone, and another one is anticyclone. Now, what is tropical cyclone? tropical cyclone, also known as typhoon in Southeast Asia and hurricane in USA. Okay, and it is also create in the open ocean, open tropical ocean, and is characterized by low atmospheric pressure. I already have told you, around 915 millibar, and winds strong circular winds. Okay, and the aerial extent of this cyclone is very high, 100 to 200 kilometer. Okay, and circular wind motion I have already told you, and wind is anti-clockwise in the northern hemisphere, and clockwise in the southern hemisphere. Okay, now the center of the cyclone is known as eye. Okay, known as eye. This extend from 10 to 50 kilometer in diameter, will be relatively quiet. Okay, but right outside the eye, very strong winds, very strong winds, and the velocity is around 200 kilometer per hour. Now this velocity of the wind decreases gradually at the outer edge, and pressure also increases at the outer edge. If we plot, okay, if we plot, this is the center of the storm, okay, center of the cyclone. Now this is the aerial extent, this is the dia of the storm. Now if you plot, you will find that if you plot the wind velocity, okay, you will find the profile is like this. That is, at the center, at the eye, it is calm, then it is increasing at the right side edges, but again it is decreasing at the last edges. Okay, this is the last edges. Now if you, this is wind profile. Now if you plot the pressure profile, then I already told you that low pressure region and the pressure increases at the edges. So this is the pressure profile. Okay. So during summer month, tropical cyclone basically originate in the ocean, open ocean at around 5 to 10 degree latitude. Okay, 10-degree latitude, and move to the higher altitude through irregular path. And as already I have told you that I told you that whenever it will move through the ocean, then it will gain energy from the latent heat and increase in size. Okay, but whenever it reaches to the earth, the energy source is cut off and the cyclone dissipates its energy very fast. Okay, and tropical cyclone causes heavy rainfall along with the heavy high damage of life and property in the land. and along its path of the rainfall, and it causes moderate to high precipitation over very large area for several days. Okay, so its areal extent is very high, along with its duration is very high. Second one is the extratropical cyclone. Okay, these are also cyclones that form outside the equatorial belt, known as extratropical region. It is also it is basically associated with frontal system. Okay, that means the favorable conditions for this type of rainfall is the interface between the warm air mass and cold air mass, and consist of large eddies and air current. Okay, and the general direction from west to east. Now, in for extratropical cyclone also, the wind moves in circular path, and the direction of the wind is in northern hemisphere. Now,
ম্যাম আগেরটাও নর্দার্ন
the
হেমিস্ফিয়ার অ্যান্টি
magnitude,
ক্লকওয়াইজ ছিল?
হ্যাঁ দুটোই আমি পরে বল। হুম।
ওকে ম্যাম।
Northern hemisphere it is anti-clockwise, and southern hemisphere it is the extratropical cyclone. For extratropical cyclone, the magnitude of precipitation and wind velocities are relatively lower than tropical cyclone, but the duration of precipitation is usually longer, and the areal extent is also longer than the cyclonic precipitation. Okay. And lastly, the anticyclone. Here, it is opposite. Okay, here it is opposite. These are the basically regions of high pressure, usually of large areal extent. For a tropical cyclone and extratropical cyclone, for both the cases, I have told you that the mean sea level pressures are very low, around 915 millibar. But for anticyclone, the with high atmospheric pressure, it is associated with clockwise wind motion in northern hemisphere and anti-clockwise wind motion in the southern hemisphere. Okay, so the weather is usually calm at the center, and winds are of moderate, so they are clear skies as well as cooler, drier air. Okay, cooler, drier air it is associated with. And when surface winds become light, the subsidence produced directly under a high pressure system can lead to a buildup of particulates in urban areas. Okay, I have told you that there should be the source of localized heating conditions. Okay, heat island should be there. So particulates in urban areas under the high pressure, leading to widespread haze. Okay, and sometimes at night time fog can form. So here the wind speed is moderate type, and generally the situation becomes cloudy, but rainfall is not very likely. Okay, but sometimes precipitations conditions will occur if relative humidity rises towards the saturation point. So this is anticyclonic precipitations. And finally, the last two terms, El Nino and La Nina. These are very much common terms to you nowadays. Uh, on a periods ranging from about 2 to 7 years, the surface across large swath of the tropical Pacific Ocean, warm or cool from 1 to 3 degrees centigrade compared to the normal conditions. Okay. Now this irregular oscillation between warm and cool patterns referred to as Enzo cycle, and it affect the rainfall distribution throughout the world. Okay, and the extreme phases of this Enso cycle is known as El Nino and La Nina. Okay, now what is El Nino? Basically, El Nino conditions means abnormally warm water conditions in tropical latitude of the central and eastern Pacific Ocean, associated with weakening of the low level easterly winds, and therefore the precipitation normally which should fall over Indonesia, Malaysia, etc., are shifted eastward. Okay, are shifted eastward, create rainfall over Peru. Okay, create rainfall over Peru, Ecuador, etc. So, therefore, the livelihood of Peru depends on basically the fishing. Okay, but because of this, heavy rainfall, at an interval 3 to 7 years, they generally not get the normal fish. Okay, so that is why they have, and this situation is generally occur during the month of December. So that is why they have given the name of this condition as El Nino. The English meaning is Christ child. Okay, and the opposite of El Nino condition is La Nina condition. That means the water in the central and eastern Pacific is cooler than the average water temperature, and therefore it is associated with strengthening of the low level easterly wind over the central tropical Pacific, and therefore it results heavy rainfall in Indonesia and Malaysia. Okay, so these are all different favorable conditions for rainfall to occur. হ্যালো, এই পর্যন্ত কারো কিছু কোয়েশ্চেন আছে নাকি? Now let me discuss the characteristics of precipitation of India. Now, I told you that precipitation varies temporally and spatially. Okay, and also I have told you that the maximum precipitation of India occurs in Cherrapunji, as well as Western Ghat Hills, and minimum precipitations occur in Thor Desert. Basically, the minimum is in Rajkot, Gujarat. Okay. Now, this picture basically shows you the isoplate. Okay, isoplate, that means line joining equal rainfall depth. Okay, line joining equal rainfall depth. Now, the climate of India can be categorized into four major groups. One is southwest monsoon, extend from June to September. One is transition period 1 or post monsoon, extend from October to November. Then winter season, that is December to February, and finally the transition period 2, that is summer, March to May. Now, what is southwest monsoon? Actually, in India, it is popularly known as monsoon, and it creates maximum rainfall. Around 75% of the precipitation in India is resulting from the southwest monsoon. Okay, and due to southwest monsoon, the rainfall occurs in June to September. Maximum rainfall occurs in July basically. Now it is quite shifted to the August also, in all parts of the India except extreme southern peninsula and Jammu and Kashmir. Okay. Now, basically, the monsoon originates in the Indian Ocean and then enters as two branches, the Bay of Bengal branch and Arabian Sea branch, to the land surface of India. The Bay of Bengal branch enters through Assam. Okay, entered through Assam, and it first covers the northeastern region of the country and turns towards westward to advance into Bihar and UP. Okay, Bihar and UP in the month of June. Okay, and the Arabian Sea branch enters through Kerala. Okay, enters through Kerala, and then it moves northwards. It moves northwards northwards from Maharashtra, Gujarat, and then it both of these two branches reaches Delhi at the last week of June. Okay, both of the two branches reaches Delhi around the same time by the fourth week of June. I don't know whether you have read in newspaper or not that in West Bengal the official monsoon entering monsoon is 8th June. Okay, and a low pressure region known as monsoon trough is formed between the Arabian Sea branch and Bay of Bengal branch, and it creates the maximum rainfall in India, extends from Rajasthan to West Bengal. Okay, and generally the monsoon retreats at the month of September. Okay, but during this period there is not continuous rainfall, but weather is generally cloudy with frequent spell of rainfall. And because of this monsoon period, you may have find that in northeastern region there are 200 to 400 centimeter rainfall in northeastern India, and in West Bengal it is around 120 to 160 centimeter. Okay, but the average precipitation due to the southwest monsoon in India is around 95 centimeter. Okay, now transition period 1, that is post monsoon. Whenever this southwest monsoon retreats at the month of end of September, okay, low pressure areas from form in the Bay of Bengal, and there is northeasterly wind flows, okay, from Bay of Bengal, which pick up moisture from the Bay of Bengal and strikes at the extreme southern peninsula. I told you that because of the southern west monsoon, all over India there is rainfall except in the extreme southern peninsula and in the Jammu and Kashmir. So in the transition period 1, the northeasterly wind picks moisture from the Bay of Bengal and heat at the extreme southern peninsula, and create heavy rainfall with tropical cyclone. Okay, with tropical cyclone. This creates heavy rainfall along with heavy loss in the life and property in Tamil Nadu, Andhra Pradesh, and Telangana. Okay, Andhra Pradesh and Telangana. Now, because of this transition period 1, you may have find rainfall during our Durga Puja. I don't know whether you have heard or not, the devastating cyclone Hudhud occurred in Tamil Nadu, Telangana, and Andhra Pradesh because of this post monsoon. Then third one is winter season, December to February. Okay, so around mid December, disturbances of extratropical origin. Okay, disturbances of extratropical origin moves from Afghanistan to Pakistan, known as Western disturbances, which cause moderate to heavy rain and snowfall in Himalaya and Jammu and Kashmir, and slight rainfall occurs in the northern plain. Okay, and because of this, I don't know whether you have read or not. Because of these western disturbances this year, you had different rainfalls in West Bengal. Okay, because of the and lower temperature, upper temperature than the normal temperature of winter condition. Even today there is also forecasting of rainfall today and tomorrow because of this western disturbances in the Jammu and Kashmir. Okay, so because of this western disturbances, there is high rainfall and snowfall in Jammu and Kashmir, but scanty of rainfall in the plain area. And finally, the transition period 2, that is summer, March to May, and during this period, because of this convective precipitation, the precipitation occurs in Assam, West Bengal, and Kerala. Okay. So these are basically the characteristics of precipitation of India, and average precipitation of India, annual average of India is 117 centimeter. বলো, কারো কোনো এই বিষয়ে জিজ্ঞাসা আছে? হুম? কারো কিছু জিজ্ঞাসা আছে? Then come to the measurement of precipitations. I already have told you that precipitations, evaporation, etc. can be expressed in terms of depth if you know the time interval and the areal extent. So therefore, precipitation is also expressed in terms of the depth to which the water would stand on areas if the rain are collected on it, and the instrument by which it is measured is known as rain gauge. Now in India, there are two types of rain gauges which are commonly used. One is non-recording rain gauge. That means here you have to collect the rainfall data manually for a specified time interval, and manually you have to collect the data, and you have to plot the rainfall accumulation versus time curve. And in India, the non-recording type rain gauge which is commonly used is known as Simon's rain gauge. And this rain gauge is also known as pluviometer, then ombrometer, hytometer, etc. Now there are another type of rain gauges where the rainfall are measured automatically. Okay, rainfall are measured automatically. Here the accumulated rainfall, okay, accumulated rainfall are plotted automatically. Okay, this accumulated rainfall versus time curve is known as mass curve. Okay, this mass curve are plotted automatically. In India, two types of automatic rain gauges are commonly used. One is tipping bucket type and another one is weighing bucket type. Now presently weather radar is used for measurement of precipitation, and you know that presently the weather forecasting as well as measurement of precipitation is very accurate because of this weather radar. Now what is non-recording rain gauge? I already have told you that in India the non-recording rain gauge which is used is known as Simon's rain gauge. It is a very simple device consisting of a collector. Here you can see one collector and a funnel. Okay, and it is basically made up of brass or gunmetal of diameter 12.7 centimeter, and it is basically covered by a cylinder of height around 308 centimeter, sorry, 30.8 centimeter. Okay, and whatever rainfall is collected through this funnel are stored within this collector, and the collected rainfall are measured by this measuring cylinder at 0.1 millimeter accuracy. Okay, every day at Indian Standard Time 8:30 a.m. the rainfall is recorded manually. Okay, but if the frequency and intensity of rainfall is very high, then the measurement can be done more than once, but collectively the data is recorded. Okay, so this is non-recording type rain gauge. Then recording type rain gauge. Okay, in this type of rain gauge, the rain gauge electric signal is generated for each unit of precipitation collected and allows automatic or remote observation with recorder or counter. Here you can see that with time the accumulated rainfall is plotted automatically. Okay, whatever rainfall is collected through this funnel is poured into a tipping bucket. Okay, whatever rainfall is collected through this tunnel poured into the tipping bucket. These buckets are so balanced. These buckets are so balanced that when 0.25 millimeter rainfall collect in one bucket, then it tips. Okay, it tips and bring the other one in position, and the water from the tipped bucket is collected in a storage can, and this tipping bucket is associated with an electrically driven pen to trace the recorder on a clockwork driven chart. Okay, so when whatever rainfall is collected within the bucket are plotted with time. So therefore automatically the mass curve is formed. So that is why it is one of the recording type rain gauge. Okay, and another recording type rain gauge I have told you, that is weighing bucket type rain gauge. In this type of rain gauge, the catch from the funnel, here also you can see the arrangement of the arrangement of the funnel. Okay, the precipitations collected in the through the funnel empties into a bucket. Here you can see there is a bucket, empties into a bucket mounted on a weighing scale. Here you can see one spring balance is there, and on the spring balance the bucket is balanced. Okay, and the weight of the bucket is recorded onto a, here you can see there is a pen. Okay, arrangement of pen are recorded into a, and here you can see one revolving drum. Okay, revolving drum which is rotated in clockwise direction, and the paper, white paper, is attached on the surface of the drum. So therefore this whatever rainfall is recorded, the pen will automatically plot the accumulated rainfall on the screen in this manner. Okay, so this is another type of recording rain gauge, weighing bucket type. আচ্ছা, এই পর্যন্ত কারো কিছু জিজ্ঞাসা আছে? এই তোমরা সব ক্লাসে আছো না বেরিয়ে গেছো?
আছি ম্যাম।
Yes, ma'am.
আছে ম্যাম।
জি ম্যাম,
সবাই
আছি।
আছে।
মাঝে মাঝে কথা বলো, না তো আমি বুঝতেই পারছি না। Now the question is that how many number of rain gauge
Ma'am.
you will, হ্যাঁ বলো।
ম্যাম কোনো
বলো।
নিউমেরিক্যাল নেই এই টপিকের ওপর?
বলবো, দাঁড়াও, আসতে দাও। Now the question is how many number of rain gauge you will install, because you can understand that the aerial extent of the rain gauge station is very small, only 12.7 centimeter, but it is represent the rainfall for a very large aerial extent. Okay, so if you increase the number of the rain gauge station, so it will associated with the cost. Okay, associated with the cost, but if you decrease the rain gauge station number, then obviously your data will not be accurate. There will be lack of data, there will be lack of accuracy of the data. So therefore you have to judiciously design the or determine the number of rain gauge stations required for a particular area. Okay, now World Meteorological Organizations already have recommended some number of rain gauge stations. They have told that if it is flat region of temperate Mediterranean and tropical zones, then ideal for 600 to 900 square kilometer and acceptable for 900 to 3000 square kilometer. And if it is mountainous region of temperate Mediterranean and tropical zones, obviously the intensity of rainfall is high, so therefore ideal one to 1 for 100 to 250 square millimeter and acceptable 1 for 25 to 1000 square kilometer. But in arid and polar zones, it is 1 for 1500 to 10,000 square kilometer. And based on the recommendation of World Meteorological Organization, India has specified the number of rain gauges as noted in IS 4978/1978. In plain area, 1 for 520 square kilometer. In region of average elevation 1000 meter, it is 260 to 390 square kilometer, and for hilly area with heavy rainfall, it is 1 for 130 square kilometer. It is the recommendation of World Meteorological Organization and Indian government. Now, if for a particular catchment area there are already some rain gauge stations, then you can determine the optimal number of stations for allowable degree of error in the estimate to the mean rainfall. Okay. For example, for a particular area, you already have N1 number of rain gauge stations. Okay, and you know that rainfall data is uncertain, random data. Okay, so therefore, this data is associated with some error. Now, if you accept epsilon amount of error for a particular area, then whatever optimal number of rain gauge stations you required for a particular area, that you can determine by using this formula. N is equal to CV, coefficient of variation by the acceptable allowable degree of error. Okay, N is the optimal number of rain gauge stations, CV is the coefficient of variation, and epsilon is the acceptable allowable error, degree of error. Okay, now how you will calculate the coefficient of variation? Let us consider for that particular area there are m number of stations which are recording the rainfall values. If P1, P2, Pm. Okay, for a specified time period. So therefore, first you will calculate the average precipitation of the area by the formula summation I equal to 1 to m pi by m. Okay, where pi is the precipitation of the ith station. Now, whenever you have calculated the average precipitation of the area, then you can calculate the standard deviation. Okay, standard deviation, that is root over of summation I equal to 1 to m pi minus p bar tar whole square by m minus 1. M minus 1 is the degree of freedom for m number of stations. Okay. Now, after calculating the standard deviation, you can calculate CV, coefficient of variation, is equal to 100 into standard deviation by P mean into standard deviation by P mean, and then whatever be your acceptable error, maybe it is 10%, then n will be the coefficient of variation by epsilon tar whole square. Okay, now if n is greater than n1, then you have to add additional rain gauge stations for the particular area. But if n is less than n1, then your number of rain gauge station is sufficient. Okay. Okay.
Yes, ma'am.
Now let me show you one problem. Determine the adequacy of rain gauge station. For a particular catchment area, you have 6 rain gauge stations. Okay. And for a particular year, you have measured the rainfall at the 6 stations in centimeter as 82.6 centimeter, 102.9, 180.3, 110.3, 98.8 and 136.7. And if 10% error is allowable of the mean rainfall, then you have to check the adequacy of the rain gauge station for the particular area. Okay, you have 6 rain gauge stations. The rainfall measured at the 6 stations are given to you, and the acceptable error is also given to you. Now you have to determine the adequacy of the rain gauge stations. Okay, so first you have to determine the P average. P average is equal to 1 by 6 into 82.6 plus 102.9 plus 180.3 plus 110.3 plus 98.8 plus 136.7. Okay, it will become 118.6. Okay, now you have to determine the standard deviation. Sigma m minus 1 is equal to 118.6 minus 82.6 তার whole square plus 118.6 minus 102.9 তার whole square plus 118.6 minus 136.7 তার whole square divided by 6 minus 1. Okay. Now if you calculate, you will obtain the result as 35.04. Okay. So you have to now determine the coefficient of variation is equal to 100 into the standard deviation by P mean. Okay, by P mean, this is sigma. So you will have 29.54. Okay, now the allowable error is 10%. So your number of optimal rain gauge station is equal to 29.54 by 10 tar whole square. That is 8.7. And you will go to the higher side. Okay, higher integer number. So your rain gauge station requirement is 9. Okay, rain gauge station requirement is 9. Now you can see you already have 6 rain gauge stations, but your optimal number of rain gauge requirement is 9 if 10% error is allowable. So you have to add additional 3 stations. Okay, you have to add additional 3 stations. বোঝা গেল? বোঝা গেল?
Yes, ma'am.
Now, whenever you will use the rainfall data, I told you the rainfall data is the random data with some uncertainties. Now, whenever you will use the rainfall data for designing some hydraulic structure, you have to check the continuity and consistency of the data. Now, during the checking of the continuity of data, if you find some data is missing or some data are missing, then whether you will discard that data, but you have already collected the data for a long time, so you cannot discard the data. So that is why you have to recover the missing data. Okay, you have to recover the missing data. There are two procedures to estimate the missing data. If you find basically the rainfall data are of two types. One is normal annual precipitation data, that means the average annual precipitation data of 30 years. Okay, and another one is annual precipitation data. Okay, one is annual precipitation data. Now let us consider you have m plus 1 number of stations. Okay, you have m plus 1 number of rain gauge station. Now for a particular year you have missed the data of the x station. Okay, you have mixed the data of the x station. You have only the data of m plus 1 number of station. Now whether you will discard that data or you will recover that data. If you will recover the data. Now if you find that the normal annual precipitation data of various stations are within 10% of the normal annual precipitation data of the missing station. Okay, you have m plus 1 number of stations, of which x stations you have missed the data. Okay, so therefore, and you have the normal annual rainfall data of m plus 1 number of stations. So how you will recover the annual precipitation of the x station? If you find that annual normal precipitation data is within 10% of the annual normal precipitation data of nth station, x station, then you will apply the simple arithmetic average procedure. Okay, simple arithmetic average procedure, that is px is equal to 1 by m summation of p1 p2 plus p3 pm, that is 1 by m summation I is equal to 1 to m pi. Okay, pi. But if you find that the normal annual precipitation vary considerably with the x station, then you will apply normal ratio method. Okay, by weighing the precipitation at the various station by the ratios of normal of annual precipitation. So how we will calculate? Px will be nx by m. Nx is the normal annual precipitation of x station. Okay, by m plus 1 number of stations you have, nx by m into p1 by N1 plus P2 by N2. P1 is the annual precipitation of first station and N1 is the normal annual precipitation of the first station, plus P2 N2 plus dot 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 PM NM. Okay, so any of the two methods you will use if you will find any of the data for a particular year is missing. Okay, now for better understanding, let me show you one problem. The normal annual rainfall at station A, B, C, D in a basin are 80.97, 67.59, 76.28 and 92.01 centimeter respectively. Okay. Now in the year 1975, the station D was inoperative and the stations A, B, C recorded the annual precipitation of 91.11, 72.23 and 79.89 centimeter respectively. Now you have to estimate the rainfall at station D for the year 1975. Okay, I repeat, you have 4 stations A, B, C, D and you have 4 normal annual rainfall data for the 4 stations. Okay, but for a particular year 1975, the A, B, C stations are operative, but due to some reason D station was inoperative, so you don't have the data of D station. So from the data of the A, B and C station, you have to estimate the data of D station for the year 1975. ওকে, এবার বলো তো কেউ একজন কি করে বার করব? শুনি একটু কি করে বার করব?
এখানে ম্যাম এম এর ভ্যালুটা 3 হলো কেন? এখানে করে দেওয়া আছে 4টে
এম
স্টেশন।
আমি কি বলেছিলাম? হ্যাঁ, আমি এখানে কি দেখাচ্ছিলাম দেখো, m+1।
ও হ্যাঁ, m+1, তাহলে m3।
ম্যাম এইখানে একটা জায়গায় আছে 80.79 আর একটা কোশ্চেনে 80.97 ছিল।
ও সরি, আমার টুকতে ভুল হয়েছে। সে ঠিক আছে, তোমরা নিজেরা ঠিক করে নেবে।
কোন ভ্যালুটা নিয়ে করবো তাহলে 80.97টা?
হুম, আমাকে প্রসিডিওরটা বলো রে বাবা। ফার্স্ট কি চেক
ওই
করব?
p1 p2 p3 এর ভ্যালুগুলো বলে দেওয়া আছে, 91.11 ওই ভ্যালুগুলো তো বলে দেওয়া আছে, আর ওই নরমালের
তাতে
ভ্যালুগুলো বলে দেওয়া আছে, ফর্মুলাটাতে বসিয়ে দেওয়া হচ্ছে জাস্ট।
কোন ফর্মুলা ইউজ করবে সেটা আগে ডিসাইড করতে হবে না?
হ্যাঁ, নরমাল রেশিও মেথড।
সেটা তো আগে ডিসাইড করতে হবে।
আচ্ছা হ্যাঁ,
সো ডিসাইড করতে গেলে কি চেক করব?
ওই নরমাল প্রেসিপিটেশন গুলো ভ্যারি করছে, ওই এতগুলো 4টে ভ্যালু দেওয়া আছে বলে।
First we have to check whether the values are within 10%, the values of normal precipitation are within 10% with the unknown station or not. Okay, that we will first check. If we find that they are within 10%, then we will use simple arithmetic average method. But if it is greater than 10%, then we will go for normal ratio method. Okay. Now here, if you check, you will find, obviously here you can see 12.09 minus 80.97 if you calculate, or even 66.59 if you consider, then you will
ওই
obtain
ম্যাক্সিমাম
obviously
ম্যাক্সিমাম ডিফারেন্স ওই নর্মাল রেনফলের ভ্যালুগুলোর
হ্যাঁ
ম্যাক্সিমাম ডিফারেন্সটা হচ্ছে 24.42 আসছে।
24, so তার মানে greater than 10%. So you can use the normal arithmetic method, sorry, the simple arithmetic average procedure. So you will go for the normal ratio method. So then it is, whenever it is decided which method you will apply, so now it is easy. So the precipitation of 1975 of dth station PD is equal to the normal precipitation, normal annual precipitation of dth station 92.01 by 3 into the precipitation of station A of 1975 divided by the normal precipitation of A in normal annual precipitation plus station B annual precipitation by normal precipitation plus for station C the precipitation by the normal precipitation. Whatever value we will obtain, we will calculate. Okay, so in this way, if any data will be missing, then you can recover the data without discarding that data. Okay, and
Answer is
another method,
99.407.
whatever you will obtain, that you will write. You don't have to, you just, here I am only showing you the procedure. Okay, now there is another method, that is inverse distance method. Okay, for this method, I have told you that if normal annual precipitation data is existing for the all the m plus 1 number of stations, then you will use this method. Okay, then you will use this method. But if this normal annual precipitation data is not available to you, then what you will do? You have to go for inverse distance method. Okay, you have to go for inverse distance method. Let us consider you have to determine the data of pth station whose coordinate you know x0, y0, and you know the rainfall data of 3 neighboring stations. Okay, neighboring stations whose coordinate is also known to you. A second. The coordinates are also known to you. This is x2, y2, this is first station x1, y1, and this is x3, y3. Okay, so you can predict the data of the x0, y0 or 0th station by inverse distance method. For that, you have to calculate the distance between the your sample station and the neighboring stations. If you have this distance, then no problem. But if you don't have this distance, then you can calculate. Okay, if you know the coordinate of the points by the formula root over of xi minus x0 minus yi minus y0 তার হোল স্কয়ার. Okay, xi minus x0 তার whole square minus yi minus y0 তার whole square. Now, whenever you have obtained that distances, then you can calculate the data of the 0th station by applying inverse distance method is equal to summation I equal to 1 to n pi by di square by summation I equal to 1 to n 1 by di square. Okay, so this is also another method. If you know the distance from your unknown station to some stations whose rainfall data is known to you, then also you can recover the data. And finally, the last topic of today's class, that is, I told you that whenever you will use any data, you have to check the continuity and the consistency of the data. Okay, continuity as well as consistency of the data. Now, how we will check the consistency of the data? By using double mass curve. Okay, by using double mass curve. To check the consistency of data of a particular station, you have to collect the data of some neighboring stations also. Okay, to check the consistency of the for a particular station, you have to take the data of the neighboring stations. And first I should tell that why inconsistency will occur. There are various reasons for inconsistency. For example, manual error. Okay, you may দেখবে যে বছরের প্রথম দিকে ধরো এটা 2021 হয়ে গেছে, তো দেখবে যে 2022 হয়ে গেছে। প্রথম দিকে দেখবে আমরা ডেটা যখন আমরা ডেট লিখি ক্লাসের উপরে, দেখবে প্রথম দিকে 21 লিখতে থাকি, ঠিক আছে। এবার একটা যদি ভুল হয় তাহলে দেখবে পরপর পরপর কয়েকটা ডেটা 21 হবে, যদি না তোমার মানে তুমি খেয়াল করো ভালো করে, ঠিক আছে। সো সেরকম ম্যানুয়াল এরর will be created if you, let us consider for a particular year you have to write data 675, but by mistake you have entry 475 or 575, so the next data will be also in the range of 575 or 475. Okay, so these are manual error. And or there may be some shifting of the rain gauge stations also, or there is some devastating calamities due to forest fire, landslides, etc. Okay, then also the rainfall pattern may have changed. Okay, so that is why whenever we will use some data, we have to check the consistency of the data, assuming that each recorded data comes from the same parent population should be consistent. Okay, should be consistent. So whatever data you will have, okay, whatever data you will have, let us consider you have data from 82 to 90. Okay, you have data for a particular station for 82 to 90, and you also have the data of the average data of the neighboring stations. Okay, now you have to plot the no, first you have to arrange the data in reverse chronological order. Okay, you have to first arrange the data in reverse chronological order. That means the latest data entry will be first one, and the last data entry will be the last one. Okay, so that is why 90th data will be your first entry and 82nd data will be your last entry. And then you will determine the accumulated precipitation for your sample station and average accumulated precipitations of the neighboring stations. Okay, and then you will plot it in ordinary graph paper. Ordinary graph paper. In y-axis, you will plot the accumulated precipitation of station X, and in y-axis, you will plot accumulated precipitation of station X, and in x-axis, you will plot average accumulated precipitation of neighboring station. Okay. And whenever you will plot it any graph sheet, always you have to write the scale. In x direction, 1 millimeter is equal to, let us consider 10 centimeter precipitation, and in y direction also 1 millimeter is equal to 10 centimeter precipitation. Otherwise, you will not get the full marks. Okay, and it is usual practice also. In field also you have to do that. After then you will plot and join the rainfall values, accumulated rainfall values by straight line. Okay, by straight line. Now, if you find that they are joined, all the data fall in the same straight line. Okay, all the data fall in the same straight line. That means your data is consistent. Okay, your data is consistent. But unfortunately, you can see here from 1987. Okay, there is the change of slope of the line. Okay, there is change of the slope of the line. That means your data is inconsistent. And your inconsistency start from 1987. Okay, your inconsistency starts from 1987. Now, whenever you have obtained that inconsistency, now I already have told you that lots of costs are associated to collect the data. So therefore, without discarding the data, we will correct the data. If we find that the data is inconsistent in nature, then we will correct the data. How we will correct the data? And also, you will only tell the data is inconsistent in nature if you will find at least 3 points are out of the original line. Okay, out of the original line, then only you will tell that the data is inconsistent. If one or two data will not fall in the same line, then you cannot tell that it is inconsistent, because it is random data and you are joining with straight line. So always it is not likely that all the data will fall in the same straight line. Okay, so here you can see that 5 data are not in the same line. So therefore you can tell that this data is inconsistent in nature, and the inconsistency started at 1987. Okay. Now how we will correct the data? Okay. how we will correct the data. For that, from the base year, এক সেকেন্ড দাঁড়াও তো, কি করব ওকে, রনি হককে আমি পাবো কোথায়?
Sorry, ma'am. Sorry.
Okay. So you have to get the slope. Okay, get the slope of the two lines. One is your original line and another one is your predicted line. Okay, so corrected precipitation at any time period t1 at station x will be equal to the original recorded precipitation at time period t1 at station x multiplied by the correction factor. Okay, multiplied by the correction factor. Now what is correction factor? Correction factor is the corrected slope of the double mass curve and MA is the original slope of the double mass curve. Okay, this is your original slope. You will draw a horizontal line and the vertical line. Okay, so this is your corrected line. This dotted line is your corrected line and this is your original line. So if you let us consider this is your x. Okay, x now let us consider this is your L. So slope of the actual line is A by L and slope of the corrected line is C by L. Now if you take the ratio C by L by A by L, then you will get the correction factor. Okay, and here your inconsistency, your plotting is in the upwards. Okay, so therefore your correction factor is less than 1. But sometimes there may be the original line will be in the downwards direction also. Okay, downwards direction also. Then your correction factor will be greater than 1. Okay, correction factor will be greater than 1. বলো এই পর্যন্ত কারো কিছু বুঝতে অসুবিধা হয়েছে? How to check the consistency of data? How to check? Let me show you one problem. Test for consistency of record. Annual rainfall data for station M as well as the average annual rainfall values for a group of 10 neighboring stations located in a nearby stations are given below. Okay, you have given the data from 1950 to 1979 for a particular station M in millimeter. and average annual precipitations of a group of stations neighboring of station M in millimeter was also given to you. Now you have to check the consistency of the annual rainfall data of station M, and if you will find any inconsistency, then you have to correct the record. Okay, you have to correct the record, and after then you have to estimate the mean annual precipitation of station M. I repeat, you are given the rainfall data of 1950 to 1979 for station M. Okay, as well as the average annual rainfall of the neighboring station. You have to first check the consistency of the data, and if you find that the data is inconsistent, then you have to correct the data, and after correction you have to determine the mean annual precipitation. So what we will do, we will first arrange the data in reverse chronological order. Okay, reverse chronological order. The last entry, that is 1979 entry, will be become first, and the first entry, that is 1950 entry, will become last. Okay, কারো বুঝতে অসুবিধা থাকলে আমাকে জিজ্ঞেস করবে। So we will first arrange the data from 1979 to 1950. Okay, of station M and station average precipitation of the neighboring stations. So after writing these two, second column and fourth column data are given to you. Okay, now you have to determine the cumulative precipitation of station M and the neighboring station. Okay, cumulative precipitation. So first entry will be 612, second entry will be 612 plus 426. Okay, third entry will be 1038 plus 825. Okay, fourth entry will be the third entry of the third column plus fourth entry of the second column. Okay, in this way you will calculate the accumulated precipitation. Okay, last entry will be the entry of the 1951 plus 676. You will have the last data. So in this way you have to determine the accumulated precipitation of station M for different year, and for neighboring stations also. The first column will be your first entry, then 588 plus 410 will be your second entry, then 998 plus 787 will be your 1785. Okay, so in this way you will calculate. Okay, in this way you will calculate. The last entry plus 780 will be your the last entry. So in this way you will calculate the accumulated precipitations for different years. Okay. Then you will plot in ordinary graph paper. The third column will be in the y-axis and fifth column will be in the x-axis. Okay. Third column will be your y-axis and fifth column will be your x-axis. Okay, and obviously I told you have to plot it in ordinary graph sheet and you have to write the scale. Okay, you have to write the scale. Now you will join it by the straight line. We will join it by the straight line. If you find that all the lines are within the same straight line without changing the slope, that means your data is consistent. But unfortunately, this data is not consistent. From 1988, there is the breakage of the data. The slope should be this. This should be the slope, but it becomes this. Okay, it becomes this. So your data is inconsistent in nature. Now, whenever it is inconsistent in nature, so obviously you have to now correct the data. Okay, you now have to correct the data. So how you will collect the data? This should be your corrected. This should be your C by L. Okay, this should be your C by L, and this should be your A by L. Okay, the corrected slope of 1969 to 1979, that is 1.0295, and the actual slope from 1950 to 1960 to 1950, actually this is 0.8779. You can see that the corrected slope is in the upwards, but whenever I have shown you in the first thing, I have shown you that the original is upwards and the corrected is downwards. Okay, so any of the conditions may create. Now, so therefore your corrected one is more, so your correction factor is greater than 1. Okay, your correction factor is greater than 1. Now, whenever you have obtained the correction factor, now you will correct the data. Okay, you will correct the data by multiplying the original data by the correction factor. 596 multiplied by 1.173. 1.173 is your correction factor. So from 1968 onwards, you will multiply the data by 1.173. Okay, you will get the corrected value of PM. Okay, you will get the corrected value of PM. And then you will determine your last part of the problem is to determine the average of the corrected precipitation. So that will be summation pi I is equal to 1 to m by m. Okay. So in this way, by double mass curve, we will basically first check the consistency of the data, and if we find that there is any inconsistent, if we find that all the lines are not in the same straight line, there is some change in the slope, then we will tell that the data is inconsistent. And whenever we will find any data is inconsistent, then we will correct the data by extending, interpolating the original slope, and then we will calculate the correction factor, and then we will multiply the correction factor with the original values to get the corrected data. Okay, এই পর্যন্ত আর কারো কিছু বোঝার আছে? কারো কিছু জিজ্ঞাসা থাকলে এবার বলতে পারো। আরো কিছু বলার থাকলে বলতে পারো। আশা করছি কারো কিছু বলার নেই, তো ইউ মে লিভ নাও। নেক্সট উইক কিভাবে ক্লাস হবে এখনো যেহেতু আমি জানি না, যদি অনলাইনে হয় তখন আমি আবার লিংক তো তোমাদের অলরেডি আছে, আর যদি অফলাইনে হয় তাহলে তো এসে ক্লাস করবে। সো এখনো যেহেতু নট ইয়েট ডিসাইডেড ফ্রম আওয়ার ডিপার্টমেন্ট লেভেল। আরে আমার উপর ডিপেন্ড করছে নাকি অনলাইনে ক্লাস করবে কি করবে না, ওটা তো ডিপার্টমেন্ট থেকে এইচওডি যা জানাবে তাই হবে। ঠিক আছে?
ম্যাম ও আমাদের ক্লাসের স্টুডেন্টই না।
ম্যাম হি ইজ নট ফ্রম
কি ঈশান? কি
ইনসান উচিহা ম্যাম, ও অন্য কোনো ছেলে ম্যাম, ভুলভাল ঢুকে গেছে।
এটাকে এখন আমি বের করব কি করে? যাক গে, ঠিক আছে, মানে ওটা তোমরা নিশ্চয়ই সোমবারের আগেই জেনে যাবে। আমরাও স্টিল নট জানি না যে
ম্যাম
মানে ডিপার্টমেন্ট লেভেলে তো একটা ইয়ে আছে, প্রিপারেশন আছে। সেই প্রিপারেশনটা হলে নিশ্চয়ই আশা করি এইচওডি স্যার একটা ইয়ে হয়ে যাবে, জানানো হয়ে যাবে, তারপরে আমরা সেই মতো নেক্সট উইকটা ডিসাইড করব। ঠিক আছে? হুম,
ম্যাম ম্যাম আমি
বলো,
এইচওডি স্যারের
শুনছি
সাথে
তো।
কথা বলেছিলাম। ম্যাম এইচওডি স্যার বললেন উনি ব্যস্ত আছেন, তো মানে এখন আউট অফ স্টেশন আছে, তো উনি আর এখন মানে কারেন্টলি এডিএস এর ইন্টারিম এইচওডি, তো স্যার বলে ওনার সাথে কথা বলতে। তো আমাদের এডিএস স্যার বললেন যে পরের সপ্তাহে মানে 7 থেকে 14 তারিখ হচ্ছে কি টিচাররা যদি চায় তাহলে অফলাইন নিতে পারে, আর যদি পুরোপুরি মানে টিচারদের উপর।
হ্যাঁ,
তো
টিচাররা
হ্যাঁ ম্যাম
আমার
বলুন।
সাথে স্যারেরও তাই কথা, স্যার আমাকে ফ্যাকাল্টি মিটিং এ তাই করার পর তাই বলেছিলেন যে এখন স্টুডেন্টদেরকে তো একটা বাফার টাইম দিতে হবে, তারা অনেকেই দূর দূরান্তে আছে, এবার হোস্টেলে এসে তারা থাকবে, গুছাবে, এরকম একটা ব্যাপার। তো সেই জন্য এটা কমপ্লিটলি হচ্ছে মানে তোমরা যা চাইবে তার উপর। তোমরা যদি বলো যে নেক্সট উইক থেকেই অফলাইন করবে, আমার দিক থেকে কোনো অসুবিধা নেই।
ম্যাম তাহলে ওটা কি আমরা আপনাকে জানিয়ে দেবো, পরে জানালে হবে কি?
হ্যাঁ হ্যাঁ, পরে পরে রবিবারের মধ্যে জানাবে, কারণ সোমবার সকালে একদম ফার্স্ট ক্লাস তো আমার। তো
হ্যাঁ
সুতরাং যদি ধরো তোমরা সব ক্লাস অফলাইনেই করো, কারণ আমি হঠাৎ করে তোমাদের অফলাইনে ডাকবো, আবার কিছু মাস্টারমশাই অনলাইনে ডাকবেন, তখন তো সেটা একটা ক্যাওস ক্রিয়েট হবে না। তো তো
ঠিক
সেই
আছে
জন্য
আমি
তো
একটু কথা
মানে
বলে
আমাকে
বাকি
একটু
ডিটেলসের সাথে আপনাকে জানাচ্ছি।
আগে থেকে জানিয়ে আমাকে একটু বলে দেবে, কেননা সোমবার ফার্স্ট হাফে আমার ক্লাস আর আমার তোমাদের মানে এ সেকশনের ক্লাস আর বি সেকশনে দেবাশিস দেবের ক্লাস। তো সুতরাং আমাদেরকে একটু আগে প্রিয়র ইনফর্ম করবে।
ওকে ম্যাম।
হুম, ঠিক আছে, বেরো।